Okay. Morning. Guys awake? Get your coffee? Okay, good. All right. So, thanks for coming. Today, talk this morning is going to talk a little about how to use Elasticsearch on Amazon, right, to aggregate Kubernetes logs. How many of you guys use Kubernetes right now? A couple of you guys, maybe? Okay. Specifically, and using the public instantiation of Amazon Elasticsearch with Cognito, right? So I think before I kind of begin and go down into the weeds, right, let's talk a little bit about what I like to call is observability in Kubernetes. And observability for Kubernetes is three baseline components, right? It's really around understanding what's happening with your application with respect to statistics, right? And that can be anything from the application all the way down to actually the Kubernetes cluster itself, and potentially even the nodes that are running underneath and the machines, right? In addition to this, you want to get all the logging information, right, from an application and a cluster perspective, and aggregate that. And finally, especially with your application running on Kubernetes, you want to see how traffic is actually traversing through that application, right? And these are like the three legs of observability and standard parts of observability in Kubernetes. Now, there's lots of different ways to implement this for your application, right? And you can go on the web and take a look, and you'll come up with lots of different answers, right? In general, what most people do, and the most standard implementation, is really to effectively go in and install, let's say, all of those components, the logging, the monitoring, and the tracing capabilities on the cluster itself. Because, hey, I'm going to put my application in, and I'm going to monitor and manage everything. And that's great if you're running, let's say, a single application and you want that cluster up and running and you want to effectively just monitor and manage that application. But in general, you're going to have lots of clusters, right? You're going to deploy a ton of them maybe as an administrator or just as a user to go run that application. It could be multiple services, right? And so a better architecture is really to utilize components such as things like Wavefront that VMware makes, right? Or Grafana and Prometheus to aggregate all of that information from multiple clusters for, let's say, the monitoring piece. Or for logging, you can take the cluster and application stats and aggregate it into Splunk or Elasticsearch, right? And that really, you have a rich ecosystem of components that are out there for you to be able to build some of these architectures. Now, in order to do this, you definitely have to go and install, I'll call them agents for right now, but if you're in Kubernetes parlance, you're going to include sidecars or pods inside of your application that instantiate or enable Prometheus, right? You'll have an instantiation of Prometheus that kind of pulls information from a cluster, pushes it out to the aggregation location. You're going to install Fluentd, right? That'll collect all the logging information and push that out to, let's say, Elasticsearch or Splunk, right? And as you develop each one of these clusters, those components go in to kind of pull that information and then pipe it out. And in particular today, we're going to be looking at how we can effectively provide aggregation in Elasticsearch, in particular Amazon Elasticsearch, the service. And we're going to install Fluentd, right, or Fluentbit, right, on a per cluster basis. And I'll show you how to do that installation, how to tweak it a little bit, and then what that looks like on Amazon's Elasticsearch service, okay? So let's first understand a little bit about logging in Kubernetes. So when we deploy a cluster in Kubernetes, right, there's lots of different logs, right? And I like to categorize them in two baseline components, right? One is your application logs. Everything that's happening inside that application, there's going to be a set of logs. Now, that can be contained inside of the application itself in the pod, or it can be actually pushed down to the cluster and stored in a specific location, /var/log on the cluster node itself. And then there's actually cluster logs, or actually the Kubernetes logs themselves, right? And those are the two baseline components of logs that you have in Kubernetes on your deployment, okay? And most people, when we talk about logging of information and aggregating, they generally talk about one aspect, and that's specifically to the Kubernetes logs, right? And I'm going to show you today both how to get the application logs and the Kubernetes cluster logs together in one shot. Let me go back to this for a second, right? Okay. In general, if you're, cluster logs or anything Kubernetes, it stores, like I said, in var/log, and that includes everything that's happening for the pod, for the cluster, for the node information itself. From the application perspective, if you ever wanted to output that application log information, you have to put it out in standard out or standard error, right? And it'll automatically, Kubernetes will pick that up and put it into this /var location, okay? And you have a couple of different ways of actually aggregating the log information, right? There's two options here, right? The first option is inside of your cluster, you could effectively take, let's say, the cluster and application, the cluster log or the Kubernetes log information, and effectively push it out to your lab backend individually, right, with some sort of a pod or have something to actually go and push it out. And then secondarily, you would take the application logs, install an agent in there, right, inside of the actual pod itself, and have that push out to the backend. That's one option. Another option is centered around pushing everything from the application, right, and taking the aggregation of that information in the var/logs in the cluster, setting up another pod that actually is an agent that pulls the information out of the var/log files and sends it to the backend, and that's option B, which is a lot more popular, I would say an easier mechanism than doing option A, right? Now I've tried both. I would say that option A is a little bit hairier to go do because you have to worry about each one of those logging agents or sidecars inside of your pods as you're deploying this stuff. So management of that, it gets really crazy. So what I will kind of walk through today is the following, right? We are going to effectively show you how to implement logging on the application, pushing it out to standard out, right? Deploy a Fluentd or Fluentbit agent, right? And then set up Elasticsearch in Amazon to pull that information, okay? Questions? Okay. So the first thing you're going to do, right, is set up Elasticsearch. How many of you use Elasticsearch on Amazon? One. Do you use the VPC mechanism inside your VPC, or do you use, let's say, a public instance inside of VPC? And that's probably targeted at the applications that are running inside that VPC, correct? Right. So this kind of works for either Kubernetes or non-Kubernetes instance, right? So I generally, if you're an administrator, you're going to want to see aggregation of all of those application information, right? That maybe you're setting them in the VPC or in Kubernetes. So what I like to do is to set up Elasticsearch as a public access, okay? Now, it's not really public access because we're going to lock this down, right? So go into Amazon, set up an Elasticsearch cluster, and what I would do is I'd pick the public, I'd set up public access, and then you're going to set up Kibana authentication, right? And the way to do this is to go run through this using Cognito, okay? And Cognito, how many are familiar with Cognito? A couple of you guys, yeah. So you would go into Cognito, we'd set up a couple of different things in Cognito, right? The first thing is you're going to set up a user pool, right? And an identity pool. And once these two are set up, it actually gives you the ability to set up the policies around them and then set up users, like, Bob, Fred, whoever you want. Give them a password, and it actually creates a role policy in there that you're going to utilize, and you're going to set up the policies inside of that to specifically give access to this cluster, right? Once that's set up, right, you would effectively then set up any users that you need, and you've kind of locked this down at this point. Second thing you're going to do right now is, now that you've got Elasticsearch up and you can get access to it from a user perspective, okay, how do I actually now push data in? So to push data into a public instance of Elasticsearch, right, you're going to have to use a key pair, right? It's still secure at the end of the day, but now to do that, obviously, you pick a user someplace that you can set up a key, right? Maybe you can set up multiple keys depending on the user, right? And then for that particular endpoint, right, you would set up a key pair, and then you can assign that to maybe a specific role that you have, right, a generalized role, or to any one or two different users that you have running. Once you've got that key pair, I'll show you how to use that key pair and actually getting access to Elasticsearch now from, let's say, a Kubernetes pod itself, right? So that in itself now gives you your components to get in to Elasticsearch, and it's secure. The next step that you would do is effectively, and this is where it kind of gets tricky, right? I think you said you were using Kubernetes, and I don't know if you've Elasticsearch, but if you set up Elasticsearch on, let's say, a Kubernetes cluster, it's really easy. You point your application, right, or Fluentd specifically, or Fluentbit, to that Elasticsearch instantiation, right, and it gets automatically routed, right? But if you're using Amazon as Elasticsearch service, where you really want to aggregate everything, you have to be able to connect to it using those key pairs, right, and have a secure connection, right, that's up and running, and it's authenticated, right? Now, the best way to do this is to use what I like to use. It's actually a Elasticsearch proxy, okay? And the proxy effectively acts as you, right, or the person or the role that has those keys that we set up in the previous step, right? Bringing up that Elasticsearch proxy will then go in and connect up to Elasticsearch and have a secure connection. And then that'll set up as a service. It'll look like a regular instantiation of Elasticsearch to all the other bits inside of that cluster, so it can point the logs to that location. And once it gets that log information in the proxy, it will, take that and then properly format it and push it out to Amazon's Elasticsearch. Okay. Now, setting up the proxy is fairly simple, but you have a couple of different options with this, right? And generally, what we're going to do here is we're going to point Fluentbit to to the ES proxy and let that aggregate everything. And Fluentbit is going to pull from the log information, right? The /var logs. So, as part of this step, right? Setting up the Elasticsearch proxy, it can be a little tricky. I use something called, and if you look at the bottom of my screen here, right, there's a publicly available proxy that somebody's created. It's built in Go, okay? And what I did is I took that proxy, I modified it, created my own container image, right, which I have up there, right, and you can see that image. It's in a repository someplace called VKES proxy that I built, and that actually has a couple of things that are inside of it for me to use. And then I can instantiate with that, set up your keys, then instantiate this proxy, and it's up and running. And then that becomes effectively the location point for all of my Fluentbit servers to go point to. Finally, what I would do now is go set up my Fluentbit or Fluentd daemon set, right? Now you have an option here, right, which is, what would you set up? Fluentd or Fluentbit? Now there's the two options can be used. There's variations or differences here, right, for you. Fluentd is a little bit heavier, right? Takes a little more memory, right? It has a lot more plugins for you to go use, right? In most instances, that's the preferred way to do it. But in Kubernetes, right, Fluentbit is becoming a little bit more popular. It's very lightweight. You can see the size differential there, right? It's very, very thin, very small. It's kind of hampered right now because it only has about 15 or so plugins, right? But for what we're doing right now, those plugins are sufficient, right? Because my application that I'm going to be running here is really just a simple LAMP stack, right, that I'm using. So I'm going to install Fluentbit, right? And use that as the log aggregator. So let's talk a little bit about Fluentbit for a second, right? Fluentbit is, it's the thinner version of Fluentd, but just from a high-level perspective, it's going to take inputs, whatever those inputs are in your config file. It could be anything. It could be your cluster information for CPU memory. It can be other components like MySQL, whatever it is from an input perspective. It'll convert it and send it out to any location you want. In this instantiation, we're obviously going to turn the output component in for Elasticsearch, right, and send that out. And to set it up, it's fairly simple, right? Go to the Fluent GitHub location, and there is actually a daemon set for Fluentbit Kubernetes called Fluent-bit-Kubernetes logging. Follow the instructions, pretty simple, right? First thing, go in and create a namespace, set up your roles, right? Create your config maps, and the config map is fairly simple. You don't even have to modify it. And one of the reasons you don't have to modify the config map is specifically because you're already creating an ES proxy that's out there. And if you look at that, it actually points to just Elasticsearch at port 9200. And so minimal modifications required there. And then you run the daemon set, and then you're up and running, right? Now, once that daemon set is up, here's what the architecture finally looks like, right? Now, you've got all you've got Fluentd running. Is this actually, oh, it does work, okay. So you got Fluentd running over here, Fluentbit, and that's pulling from my /varlog information. Now, what I've done in each one of these pods is also I have gone into Python, I've instantiated a standard library for logging, right? And I've spit everything out to standard out, right? And the errors are going to standard error. So those are getting captured actually inside of the /varlog file itself, right? And then Fluentbit is pulling all that information along with the Kubernetes, converting it and sending it out to the ES proxy. Questions? Okay. And so let's take a look at the output, right, for a second. Just go live. Okay. So here is my instantiation of Elasticsearch. And you can see it's been logging a bit of information, right, over the last day or so. And I turned it on yesterday, right, just to show you guys what's there. And you can see it just turned on, right, and it's been starting to log information. Let's just go back to the last 15 minutes now. And I'll point out a few things here, right? First and foremost, I'll start with, let me see if I can scroll down and find some of the application information, right? And we'll show you that. Okay, here we go. So here's one, and this is actually a log that's coming in from my application itself, right? And this is a call to API, version 1 of the API that's actually getting a set of data from the MySQL, right, database, going through a Flask server, right? And this, every time that gets hit, these logs get output, right? And obviously it's getting captured. And so that this is now capturing that log information. And then if we scroll up a little bit more, we'll start seeing actual Kubernetes information in here, right? We can take a look over here, and this is giving me output from specifically, is more of my application information, right? We'll just pull a couple up here for you guys to see, right? Here's one that talks a little bit about updates that Kubernetes is doing, right, specifically on the data plane, right? And so everything that's happening right now is getting logged and is getting pulled up, right, into Elasticsearch. So that's pretty simple, right? But it's not as intuitive to get this running, and mostly because of the fact that a standard configuration that most people will see on the web, to get into Elasticsearch will not use the Elasticsearch proxy, right? So using the Elasticsearch proxy is probably the most important component of all of this. anything you see on the web will just say, oh yeah, go and install the Fluent daemon set or a Fluentbit daemon set, and it should be up and running. That little connection that you need to interconnect basically the cluster with the right keys into Amazon Elasticsearch is important to get that set up and running. Okay, and that's a quick overview of how to get some of your aggregation logs into Elasticsearch. Questions? Yeah. You can do it with roles, right? You have to find there's a couple of different agents that are out there, right? That'll do it with roles, and you can set that up if you needed to, right? I just chose to use it. That's all. Yeah, I mean, it's just a variant of one or the other, right? This one, right? The thing is with the role, right? Look, I did some searches. That's what I found, right? I found that the most easiest, right? But you can build your own. I mean, people have gone out there and obviously built different proxies, right, that you can use. Role is a lot better to use, a lot more secure, obviously. So if you find one, go use it. But you have to use sort of a proxy to go do this, right? Otherwise it's going to break and brittle. And then you'll be sitting there, I mean, just getting it to install with a regular daemon set and going in and looking at those configuration files and trying to manipulate them, there's really some wacky things that have to happen. In some cases, you got to turn off TLS, you got to turn TLS on, you got to change your port numbers because it's 44. I mean, going into Amazon itself, it's not 9200, right? It's going to be 443. And there's a whole bunch of problems that occur there, right? Because the configs in Fluentd are not that straightforward, right? So this allows you to have a standard Fluentd config without having to worry about it. It thinks it's faking the system out, so to speak, right? Yeah. So this is, okay, so I'll answer two parts of this, right? One is this is Fluentbit, right? Fluentd is the same. So if you install this Elasticsearch proxy, or you can find one with a role, right? For instance, right? I can swap this out. I mean, I didn't label this, but this is Fluentbit. I can swap this out and put Fluentd if I wanted to. Same difference, right? There's a couple other things that you got to do with the config here. Works like that, right? Not a problem. And same thing as a proxy, right? Where would you want to send it to? You can put it to output to anywhere you want it to at that point, right? Now, we're at Amazon conference. We're going to use Elasticsearch. Here's one option. CloudWatch, I haven't tried that. Right. So my guess is, have you been playing with EKS? Yeah. Where do those logs get sent? Yeah. So I mean, right. So if you use EKS, obviously it's going to bring it up. It's all integrated, right? But the reason I'm showing you this is that that Kubernetes cluster could even be on-prem, all right? It could be an EKS. It could also be a COPS instantiation of Kubernetes, right, which is on EC2 at that point. In this instantiation, I'll do one last slide of what we used, right? We used our VMware Kubernetes service, which actually runs on, against Amazon and sets it up on EC2 in your tenant, and you can use it, right? But it also will do it on-prem and stuff like that. So the reason for you showing Elasticsearch is you want one aggregation point. If you use EKS, yes, it's awesome, right? Because it sets everything up. But then if somebody else is running a cluster in some other instance, depending on your line of business or whatever, you want that aggregation point, right? That makes it a little bit easier. Now you could probably pick CloudWatch if you wanted to. No problem. I just haven't tried that. Yeah? Any other questions? Okay. So just as a quick note, the Kubernetes thing that I used in this setup was something called VMware Cloud PKS. It actually runs in Amazon. It's a SaaS service that we built that allows you to effectively bring up a Kubernetes cluster in 3 steps, right? There's no CloudFormation templates and everything, and it brings up those clusters on EC2 in Amazon for you to use, right? And this cluster was running in Amazon on that instantiation of it. It's a SaaS service. You can swipe your credit card, right? Go use it and bring up clusters literally in 3 steps, right? And that's what we used. But obviously you can use any Kubernetes cluster in this configuration that I showed you today. Okay? That's it. Thank you guys.